Okay, let's go through the contents of this video. First, I will explain you about the branches of artificial intelligence and then machine learning. And then I will explain the supervised, unsupervised, and the reinforcement learning. After that, I will explain the deep learning and then deep learning versus machine learning. And then I will explain the convolutional neural network, CNN. And then I will explain some popular deep learning architectures such as Alexnet, Googlenet, etc. Then I will explain you that how one can create the deep learning model with the following approaches. One is the training from scratch and other is the transfer learning. So let's go through this video. Now let us see the different branches of artificial intelligence. So we have the different branches of artificial intelligence such as the machine learning, ML, and very popular one that is NLP, the natural language processing. We have expert systems and then computer vision and then speech, planning, and robotics. So among these various branches of artificial intelligence, the machine learning branch is the most popular one. So which has further branches of deep learning, reinforcement, supervised, and the unsupervised learning. So in this video, I'm going to explain all these. I mean the unsupervised, supervised, and the reinforcement in brief, and then I will emphasize more on the deep learning. So let us see the branches of machine learning. So as I said, under this big umbrella of artificial intelligence, there is a machine learning, which is the subset of AI, and then machine learning has the supervised, unsupervised, and then reinforcement learning, and there is a deep learning. Okay, there is a deep learning which has interaction with all these three. When the deep learning interacts with the reinforcement learning, there is another branch which is the deep reinforcement learning. Okay, so I will explain all these three. So let us see the supervised learning first. So in this image, we can understand the supervised learning. In the supervised learning, actually, we give the categorized or labeled input and output data to the machine algorithm. As you can see in this figure, we give the different images of cats, okay, to the machine learning algorithm, and we label them as cat. That means we are defining the output also, that these images are related to the category of cats. And once this training is complete, then if you give some images which are not, of course, the part of training, these are the new and uncategorized or unlabeled images, then this machine algorithm is now able to identify that whether the given input image belongs to cats or non-cat category. So this supervised training can be used for following two types of applications. One is the classification and other is the regression. Okay, so we have a list of different training algorithms which are very popular in machine learning, which work on the supervised learning. So these are the decision trees, naive classifications, SVM, random forest linear regression, and then ordinary least square regression, logistic regression, and ensemble methods. Now let us see the unsupervised learning. So that is explained in this figure. So here we do not define the output, okay, as in case of supervised learning we define the category or label of the image. So here we give uncategorized or unlabeled images as the input, you can see here. So we have different types of images which are given as input to this machine learning algorithm. So here the machine learning algorithm actually tries to find some hidden patterns or some correlations sort of things out of these images. So once it is trained, now it has the capability to classify or clustering the image depending on its feature matching to which group. So if you give some input image to this machine algorithm, then it has the capability to identify whether the input image belongs to the group 1 or group 2. Unlike the previous case, that means the supervised learning, it does not tell you whether the input image belongs to the either cat or dog. Okay, it only gives this information that the input image belongs to this particular category or group 1 or group 2. So it can cluster the images in different groups. So that's why it is mainly used in the clustering and then NMLI detection sort of problems. So we have different algorithms which work on the unsupervised learning, which are very popular, such as the k-means clustering, a priori algorithm, PCAs, which I have already explained in one of my videos, and then SVD, singular value decomposition, then an ICA, independent component analysis. Now let us see the reinforcement learning, RL. So unlike the supervised and unsupervised learning, where the input is the static data set, the RL works with the data from a dynamic environment. That's the basic difference. And the goal of RL is not to cluster or label the data, while it gives the best sequence of actions that will generate the optimal outcome. Okay. So RL allows a piece of software, which is known as the agent, to explore, to interact, and to learn with the environment on the reward and punishment policy. So here we can understand by this figure. So our agent receives input from the environment, which are known as the observations, and on those observation basis it gives some actions on environment. So there are some changes in the environment. Now if these changes are as per our requirement, then some reward is given to this software or this agent. So as you can see, so it receives the rewards as well as observations from this changed environment. So now our software or agent will work in such a way that the rewards can be maximized. So to maximize the reward, it gives further actions on the environment. So that's why on this reward policies, this agent gets trained. So this is how the reinforcement learning works. So now let us understand the deep learning. The deep learning actually is based on the deep neural network. What do we mean by actually deep? The deep usually refers to the number of hidden layers in a neural network. The traditional neural network contains only the 2 to 3 hidden layers, while the deep neural networks have hundreds of hidden layers, and they can have as many as 150. So these deep learning models actually are trained by the large sets of labeled data, and these neural network architectures that learn features directly from the data without the need of any manual feature extraction. So in this figure, you can compare a simple or ordinary neural network and the deep neural network. So in simple neural network, here you can see there is only one hidden layer, while in deep neural networks there are more than, actually this is just representation. As I said, there are hundreds of layers in the deep neural network. As said by Jeffrey Hinton at the Google, he says that the deep learning is an algorithm which has the no theoretical limitations of what it can learn. Okay, so the more data you give and more computational time you provide, the better it is. But the deep learning has some limitations also, as the deep learning always requires a huge amount of training data. So if you are training a particular deep learning algorithm to identify particular objects, then you have to provide the millions of images for better accuracy. Obviously, when you are providing the millions of training images, then extensive computational power is required. And the architectures can be, of course, complex and must often be highly tailored to a specific applications. And the resulting models may not be easily interpretable. So at the end, after training, what we get is not easy to understand. Actually, as I said that we need the extensive computation power, so we need the GPUs and TPUs. GPUs mean the graphic processing units, and the TPUs are tensor processing units. They are exploited for heavy computations. And for low end processing, we have the FPGAs and the CPUs, I mean the central processing units. Now let us understand the difference between the machine learning and the deep learning. In the machine learning, we first extract the features from the input images. So in case of cat versus dog classification, let's say, the features may be the whiskers, ears, eyes, etc. And these feature extraction parameters are defined by us. The algorithm has nothing to do what types of features it has to calculate. We ask the algorithm to find the features based on the defined parameters. So on the basis of these features, some classifier gives the output. While in case of deep learning, we do not provide any features, okay, as in this case. So it learns the features from the set of input data which are important for classification. So that is the main difference. So let us understand this difference with one more example. So here you can see we have a set of input data. In traditional machine learning, first we find features, some special features from these images. For example, if we are finding whether the input image belongs to car or not, then these features may be, let's say, the color, edges, and some other shapes, parameter, etc. And once the features are extracted, then these are given to some classifier, such as SVM or KNN, etc. So that classifier will identify whether this image belongs to car, truck, or bicycle, etc. But in deep learning, with the input set of images, we do not find any features. So this part is missing in this deep learning. So deep learning is end-to-end learning where features are automatically computed by the deep neural network. So at the end, it has the ability to differentiate between the various objects, whether the given input image belongs to car or not. So in this table, you can summarize this, that machine learning, of course, it can work with a small data set for the good result. Okay. So the number of input images for training required are less as compared to the deep learning, where deep learning obviously required the millions of images. Since less number of input images for training are required, so obviously it's a quick training. That means that traditional machine learning is a quick training, while this deep learning requires lots of computation and time for training. But the machine learning need to try the different features and classifier combinations to achieve best results. That means to achieve the best accuracy, we need to try the different combinations of classifier as well as these features. So in some cases, some features may not work, while we have to change the features or identify the new set of features that can give the better accuracy. So after trying those combinations, we observe that after certain experiments, this accuracy becomes flat. Okay, so we don't have many choices left to try. But in case of deep learning, if we increase the computation, we increase the number of input, then accuracy is unlimited. So with increased amount of input data, accuracy can further increase. So that's the main difference between machine learning and the deep learning. Now let us see the convolutional neural network. So it is one of the most popular type of deep neural network, which is known as the ConVNet or CNN. A CNN convolves learned features with input data and uses two-dimensional convolution layers, making this architecture well suited to process the 2D data such as images. So this is the architecture of CNN. Here you can see that we have input images. So it goes through the series of operations, and these operations are actually the repetition of the convolution and then rectified linear units and then max pooling. Actually, these operations are done by the various hidden layers of CNN, and at the end there is a fully connected layers which is used for actually the classification. So which can classify your input image based on this the scores it achieves after this fully connected classification. So in this figure we can see that there are different filters. These are actually the learned filters. We have not defined these filter architectures. The CNN from the millions of images itself learned these features. So these small filters are used for convolution with these images, input images, and then we get some output. This output actually is used as input to the next label, as you can see in this figure. So output of the first convolution ReLU and pooling is input to the next label, and so on, and at the last we get the classification or output. This is the another figure which you can understand these operations. So the first few hidden layers are used for feature detections. As I said, in this case, in this figure, I mean these filters. These filters are determined by the algorithm itself after training with millions of images. Okay, so we have these filters which are used in the convolution with the images, and after that we have a ReLU operation, that is a rectified linear operation. Actually, what happens in this, after the convolution, if we get some negative value, they are actually mapped as 0. I mean the output of a the filter, if I get, let's say, -1, 2, 0, 4, then after ReLU it becomes 0, 2, 0 and 4. So that is operation done by the rectified linear unit. And now what pooling is done? Actually, pooling is a nonlinear downsampling to reduce the dimension of the output. So if we get this large amount of output, then after pooling you can see that it reduces in the dimension. So how pooling is done? So pooling is done actually on the basis of maximum number. For example, in a 2 by 2 set, I get this 3, 8, 9 and 10. Then after max pooling it reduces to a single unit of 10. That means 10 is maximum of all those 4. So 10 is output of max pooling. So this is done in various hidden layers, and in the last we have the fully connected layers for classification. So at in the last layer with a softmax function we provide the output. So whether the input image belongs to a particular category or not. So I mean some values are given to each object category, and for example, let's say 0.9 to car, to truck it is 0.7, to van it is 0.6, and to bicycle it is 0.1, sort of things. And the object which has the maximum value, let's say 0.9, the car object has the maximum value, so that object is your output. So now let us go through some popular deep learning architectures. So very famous one is the Alexnet. It's a simple yet very powerful network architecture which has 23 hidden layers. It utilizes the CNN with, of course, the same architecture which I have just explained. I mean the convolution, linear rectified units, max pooling, and then fully connected classification layers. The key feature of Alexnet is training on the GPU architecture. That means it supports the GPU architecture for training. So that's why the training speeds up because of the GPU architecture. The next is the VGGNet. So the VGG network was introduced by the researcher at the Visual Graphics Group at Oxford. That's why it is known as the VGG. So this network is especially categorized by its pyramidal shape, where the bottom layers which are closer to the image are wider, whereas the top layers are narrower. So it's a pyramid type of architecture. It has a 19 hidden layers, and it's a slow in training. The next is the Googlenet. The Googlenet, or known as the Inception Network, is a class of architecture which is of course designed by the Google. It was the winner of ImageNet 2014 competition, where it proved a very powerful model. It has 144 layers, so it's a big one. It offers the parallel architecture, which shows a drastic change from the sequential architectures of the previously used model. For example, in Alexnet, it was a sequential architecture, but in Googlenet, it offers a parallel architecture. Now there is a Resnet, another very popular one. It's it is known as the monster among these architectures, because it has a 152 hidden layer. Okay, so residual networks, which are known as the Resnet in short, consist of multiple subsequent residual models, which are the basic building block of Resnet architecture. We have the RCNN, again very popular one, region-based CNN. So region-based CNN architecture is said to be the most influential of all deep learning architectures. So RCNN is to attempt to draw a bounding box over all the objects present in the image, and then recognize those objects in the image, as you can see in this figure. So we draw the bounding boxes for various objects, and then these different objects are recognized by the CNN. And we have the YOLO, that is a short name of You Only Look Once. So YOLO is the current state-of-the-art real-time system built on the deep learning for solving image detection problems. Actually, YOLO is widely used for real-time applications. So it is first divides the image into defined bounding boxes, and then runs a recognition algorithm in parallel. That's why it is faster to identify the objects of those boxes, which object class they belong to. So after identifying this class, it goes on merging these boxes intelligently to form an optimal bounding box around the objects. As you can see, the image is actually divided into the various blocks, and each blocks are given for identifications. So first these blocks are linked to a particular class. So all those blocks which are related to a same class, they are combined together. For example, the different blocks over this dog, after the classification, they result in the same class. That's why a bounding box is drawn over this dog. This is how the YOLO finds the objects in an image, and these boxes actually are processed in parallel. That's why YOLO gives the faster recognition. We have the various other deep neural networks, such as SqueezeNet, SegNet, and GAN, etc. Now let us see how to create and train deep learning models. So we have a deep model. We can train it using two ways. One is we can train from scratch, or we can use a transfer learning. Let's see what do we mean by the training from scratch and transfer learning. So training from scratch means to train a deep neural network, we need a very large amount of labeled data set. That means millions of images. And this is good for new applications or applications that will have a large number of output categories. So this is a less common approach, because it needs a large amount of data and the huge amount of learning time. So typically it is done by the various service providers or big companies such as Google, Amazon, etc. to train their model from the scratch. They have the facility, they have infrastructures to train the deep model like this. For an individual, it is not possible even to build a database of millions of images. So obviously, the computational power needed is extensive. That's why they have use the GPUs and TPUs. TPUs are actually known as a tensor processing unit. This is actually the spatial architectures of processors, which is proposed by the Google in their training. So this is actually specifically related to the Google. This is the spatial hardware architecture, which is particularly designed for the deep neural networks to make the training faster. Now let's see the transfer learning, a process that involves a fine tuning of a pre-trained model. So suppose some model which is already trained from the scratch, I can use that model for my own classification problem or object identification problem using the transfer learning. So we start with the existing networks such as Alexnet or Googlenet. They are already trained by their providers, as we said, from they have gone through the training from scratch. But now I can use these pre-trained networks for my own applications. Even I can use them for previously unknown classes of objects. So after making some tweaks to these networks, I can perform a new task such as categorizing only, let's say, dogs or cats instead of categorizing 1,000 objects. For example, the Alexnet is trained for 1,000 different objects, but I can use Alexnet to differentiate only the 2 objects such as, let's say, dogs and cats or something else. So this also has the advantage of needing much less data and the processing thousands of images. So instead of working with the millions of images, I can use them with hundreds of images or thousands of images. So obviously the computation time will drop from days or weeks or even months to the minutes or hours. So transfer learning actually requires an interface to the internals of a pre-existing networks. I mean, I want some internal details or some internal parameters of these pre-trained networks. So I can tweak them, I can modify them, so I can use them for my own application. So this figure tells that what is the training from scratch and how it is used as a transfer learning. So this first one actually depicts training from scratch. So we have a very huge amount of data which is given to our source model. So let's say this is my Alexnet or Googlenet model, so which is trained with the millions of images. As you can see, the large amount of data and labels are required. So once it is trained, I can transfer some internal details, as I said, some internals of pre-existing networks. So some internal detail I can borrow from the source model to make my target model on my local machine, and I can train this target model with a very low amount of data, as you can see. So to do my own object classification work or something else. So this is how the transfer learning works. We can create and train deep learning models in 2 popular software environments. One is the MATLAB and other is Python. These are very 2 popular. Also, depending on the computational power, or the hardware needed, we have choices. For example, the cloud-based, for example, the Google Colab. Suppose my training data is huge and my local machine is not able to train the model. It requires lots of time. Then I can utilize the Google's facility. I can utilize their hardware for training my model. So that is a cloud-based training. Or I can use the local machine. That means, for example, my own PC or laptop. But my PC or my laptop has 2 different hardware category. It may have the CPU and very low power GPU, generally the integrated graphics. So if I have only the CPU and low power GPU, then I can use it for a very low amount of data, and of course it will require the more training time. So it is slower but affordable. Most of us, we have this type of configuration, and those machines which have GPUs, I mean, they have they have dedicated graphics card in their PCs or laptop. Then we can use them for faster training, but of course the extra money is required for utilizing those GPUs, I mean the graphics card, in the machines. So that's it for this video. I hope you have liked this, and I really thank you all for watching this video. So wait for the next video. Till then, goodbye.